A scale factor is simply the number that we would have to multiply by to make a shape be a larger or smaller size. So when we think about that, so if we were to double something, we would take something and we would multiply its sides by 2, and then it would be twice as big. So what you want to remember is that if your scale factor is greater than 1, your new shape will be larger. And if your scale factor is less than 1, then your new shape will be smaller. So if we take something and we multiply it by half, it's going to now be half the size that it was before, so it's going to be smaller. So for a couple examples of how we would do this, we've got some shapes. And so if we wanted to take this looks like square that is 18 by 18, and we wanted to multiply it by something to get a square that is 66 by 66, then we would have to figure out what number we would have to multiply 18 by to get 66. The easiest way for us to do that is to write it as a quick little equation. So if we take the initial box, so this is box A, and we multiply it by some value, and we need the answer to equal 66 to get box B. Now we would simply divide both sides by the value of 18, and that's going to leave us with x equals 66 over 18. Now, nobody wants to multiply by 66 over 18 if we can make those numbers smaller, so it's now a fraction that we can reduce, which means we can divide top and bottom by 2, at least to start, and that's going to give us a smaller fraction that is 33 over 9. And now I can recognize that this also has a common factor of 3, so I can divide top and bottom by 3 to get my final answer of 11 thirds. So if I multiply 18 by 11 thirds, I am going to end up with a value of 66. Now thinking about this scale factor, 11 thirds is greater than 1, so that means I am trying to get a square that's bigger, which is a way that we can look back and decide if we have done it correctly. So I'm expecting a number that's greater than 1, and 11 thirds is greater than 1. If I wanted to check my work, I would just say 18, I would multiply that by 11 thirds, and then that does indeed give me a value of 66. In this second example, we're trying to take a triangle that has sides of 91, and we're trying to make it smaller into a triangle with sides of 54. So once again, I'm going to set it up with 91 times some number is going to equal 54. And now I'm going to just divide both sides by the value of our starting triangle, which in this case, we're going to call them A and B again. And that's going to allow me to see if that will work. So x is going to equal 54 over 91. And then I can see if this can reduce. 91 is not divisible by 2 or 3 or 5. Might be divisible by 7, but 54 is not. And not divisible by 11. So I think this might be the smallest that this fraction can be. And a quick check on my calculator does show that 54 over 91 is the smallest value that this can be. So that means that if I were to multiply my initial 91 times my scale factor of 54 over 91, it would indeed give me a value of 54. So if you don't want to set up the equation, you would just want to remember that you are doing the side of shape A, which would be your initial shape, and then you would divide it by the same side, so the equivalent side of your ending size, and then you would know what number you would have to multiply by. And as always, we should always reduce to use smaller numbers because smaller numbers are easier.